So, actually, let me start off by, I guess it doesn't matter which way you're pointed. If somebody makes a claim, like, if you and I are walking down the street, and you see somebody walking towards us, and they say, that person is 47 years old. Can you imagine that? Just walking down the street, your friend looks over and she says, that person coming? Yeah, that guy? Yeah, that guy. 47. That guy's 47. Okay. How would you test that claim? You obviously would do what if you felt up to it? What would you do? Ask them. Say, how old? If they say they're 48, is your friend impressive at all? Or, is that like, who gives a shit? What do you guys say? So maybe age is a little bit, because I'm sure in your head you got somebody who's exactly 47, you're like, 48, that's no, but people don't look their age. Are you with me? So, I mean, to me, that would still be impressive. Somebody with me. So when you test a claim, it doesn't have to be exactly equal to what they say. It has to be close enough to what they say. Does that make sense? So if we looked up, like if, sorry, a little Rain Man. So a bunch of toothpicks falls on the floor, and my friend says, it's exactly 213 toothpicks, definitely 213 toothpicks. And we count them because we're bored as all shit, and it comes out to be 200. Not 213. I'm still kind of impressed, right? Do you guys kind of follow? So the idea of how close you have to be. Now, if he's 13 years off of somebody's age, screw that shit. That's not impressive. Yes?
Is it kind of like how you guess how many jelly beans are in a jar?
Yeah, well, yes. And math people at the worst, because we overthink it. We're like, let me count in this many, and then approximate the number, and then it's about this volume, and I say this, you're off by 3,000. Shit. There's always somebody who doesn't know any math at all, and they're like, it's all right. Not bitter. It's sort of like how I can't really play pool all that great. And you'd think I could, but no. Or poker. So, sort of, yeah. I mean, if somebody just glanced at a jar of jelly beans, just went, yeah, there's 4,297 jelly beans. And then we counted them, and they came out to be 4,003. I'm still like, holy shit, that's really amazing. Stay with me. I know. But it died of it. This idea of how close you have to be, that's what we can control in this. What I do is, I say, so I claim that it's something. So somewhere close. So this is what I'm calling close. So I claim it's 4,137 jelly beans. So the only way to say that I'm full of shit, that I suck at this, is if it's far enough away from that guess. So if I said 4,137 and it was actually 1,100, that's obviously like, you don't have a magical jelly bean counting ability, which number one would be really strange X-Man mutation to have. Jelly bean man, we need you. Sorry. So if you get if the actual thing was 1,100, then screw you. It's too far away from what you thought it was. Stay with me, come on. You guys get a feel for this. You get a feel for this? What I'm trying to get a feel for is a huge part of hypothesis tests is exactly this. All right, let's say you're right. But then the actual thing is this. So that is so far away from what you said that what you said is apparently wrong. Your claim is kind of like, I can guess jelly beans. Your claim is wrong. Maybe better is like, if you claim you can make 80% of your free throws, and you take 100 shots, and you make 79 free throws, what percentage of free throws did you make? 79%. So I'm like, your claim sounds really good. Why does it not have to be exactly 80? Because that's 80% of 100 is 80. Why does it not have to be exactly 80 for me to feel good about their claim? Because what was their claim? They can make 80% of all their free throws. So you have to watch them over their entire life. Watch every free throw. You can't do that, so you take a sample. So the sample doesn't have to be exactly what they say. It just has to be close enough to what they say. So there's two steps that's the most important steps in a hypothesis test. What is far enough away? And did I make it far enough away? So I'm like, I think you're wrong. So this is how far enough. If you get further away than this, you're wrong. So if you take 100 free throws and you're like, I can make 80% of my free throws, and you make 20 free throws, you're like, you got that backwards. You guys kind of with me? Now I have to kind of go to extremes in this example because we haven't defined what far enough away is. So, for example, if I say 80% of my free throws I can make, and I take 100 shots, and I make 70, what do you think? It's a little subjective now, isn't it? Some of you guys are like, yeah. Some of you are like, no, screw that guy. 70%. It's not 80%. Do you guys semi with me here? I mean, it's... All right, so there is a step that we do in this class that is not done in real life. But the reason we do it is because we don't have a good enough feel for what we actually do in real life. And the thing that we do is define what far enough away is. That's not done in real life for most situations. Okay, maybe. So let me stop talking about generalizations. Let's actually look at a problem. All right, you're all like, this ain't going to be what I got to do my homework, Jeff. All right, that'll blame. So everybody's got this sheet here, right? Phil, the researcher. I think I made this. This is way back. Let me see if anybody can date anybody. There was Tom. Was it Tom the plumber? Tom the. Screw it. I can't remember the exam. Back when Sarah Palin was the running mate. And there was Tom the plumber or something. I can't remember. Like Tim the tool man. Huh? Bob the builder? Not Bob the builder. It's along that same vein. So I made Phil the researcher to be like Tom the plumber. So Phil the researcher believes that the northern Minnesota lives longer in captivity. So he's made a claim. Why do you think that claim makes sense? He thinks that the northern Minnesota coyote lives longer in captivity. It says nothing about what their quality of life is, but they live longer in captivity than they do in the wild. Why do you think that might be? Why does that claim make sense? No natural predators, right? The humans are there, but they're not humans that want to kill them. They're not getting at somebody's chickens. So, like, they got to kill you, dude, right? Also, they have guaranteed regular meals that are probably free of disease. And you guys kind of with me? So, your claim, of course, sort of has to make sense to even start something off. Right? So this claim seems to make, now at the same time you can argue that being in captivity makes them, they can't roam as much, they can't form normal bonds with other coyotes as they would in the wild, all that kind of stuff, but okay, but at least this claim says, yeah, this makes sense to check this out. We know, now somehow, this is magic, I know. So you have to always start off with some assumptions when we start something off. We're going to learn more and more so we're able to handle less and less certainty. But right here, mean lifespan is known to be 7.25 years. We just know that, right? And we know also magically that the population standard deviation is 3.27 years. So he takes a sample of 41 northern Minnesota coyotes. So I really want this to make sense. We would have information about all coyotes. That's based on samples, but we're going to assume that this is true, that the mean lifespan of all coyotes is 7.25. Population standard is 3.27 years. Are northern Minnesota coyotes a subset of all coyotes? Yes, so those are true for them too. Should be true for them too, if nothing is different about that little group. If you like it. So we take a sample of 41 and find a mean lifespan of 8.65 years. So I know I've made this point before, but just to really make this point hard, let me make sure this is going. Yay! Why don't I just stop there? Why would somebody think you could stop there? What was his claim? They live longer in captivity. Oh, they live 8.65 years long. So, Jeff, what's all this shit? Why do I have to do all these 5 steps, Jeff? You're done. Why am I not done? Of course. Why am I not done? Why can't I just stop? 8.65 is greater than 7.25. Yes? And some of you guys are like, why is he arguing against making this do this? This doesn't make sense. Because his argument is crap. Right. Why is it crap? Why can't I just stop? That is a bigger number than that. Why do I have to do anything? Why do I have to prove this?
That's a sample.
That's a sample. I would put a lot of money on a sample mean being different than the actual population mean. Now, if it's a good-sized sample, 41's not the best, but at least it's greater than 30, right? Bless you. But it's still not a very large sample. Bless you. And if it's random and it's larger, I would expect the mean to be close to the real mean. That's why it's big in the middle, right? Okay, I like it. So what I got to do is based on that same idea we were talking about earlier. I've got to show, if I think he's wrong, let's see. Well, let's say this. If I think he's right, because he says live longer. If he wants to show evidence that they do live longer, not only does he have to find a sample that's bigger, he did that, but they also have to be bigger enough, far enough away from the mean, from the 7.25. Okay, maybe. Are you guys getting a feel for this? A little bit. Now, so the very first step in a hypothesis test is to state the freaking hypothesis. That should just make sense. Your first step is, tell me what the hell you're going to be talking about. Step 1. And this page, step A. So can somebody write in math what the claim is? What is he actually claiming? You do. Tell me in English what this guy is claiming.
Coyotes live longer.
Say again? Huh?
The coyotes live longer in captivity.
Good. So the mean lifespan of captive coyotes
It's 7.25 years.
is how related to 7.25? Their mean lifespan is how related to 7.25? This is his claim. Their mean lifespan is greater than. So what's the symbol for mean? Mu. Greater than 7.25. I would never make a claim about sample data that's stupid, right? And I'm not calling anybody stupid, but I want you to realize that would be dumb. I'm not going to make a claim about sample because I can see the freaking sample's 8. I claim it's 8.6. Good job. We see it's 8.65. Or if you claim, I think it's less than, dude, it's 8.65. You can see it, right? I never am going to put anything about the sample in this. I'm going to make a claim about a population. Maybe. So I'm not going to put the 8.65 number here. That doesn't make any sense. I wouldn't make a claim about something I can see. Now, okay. I always relate, if there's this stance, that it's greater than 7.25, there must be an opposite stance. Right? Obviously. What's the opposite of greater than 7.25? Less than or equal to 11. All right. So I think about these guys. This is the null hypothesis, and this is the alternate hypothesis. Heretofore known as the hoes and the highs. So the null hypothesis will always have an equal sign. He's the guy who thinks Nothing's changed. It's just equal to this. H1 is the guy we can actually test its statement. So would a sample ever show evidence? If my sample was 7.25 years, if my sample was 7.25 years, is that proof or evidence that the real mean is 7.25 years? No. Any sample I take, I can't trust its mean inherently. I can make a confidence interval, get a feel for how close it is, all that kind of stuff. Yes? With me. A little bit. This is huge, I want this statement to be the one I can test, the one that I can show evidence for. And that's always going to be the one that does not have an equal sign. If it has an equal sign, I can't show evidence for that. I can show that something looks different from something else, but I can't show that it looks equal to something. I love you guys. This is a little weird, I understand. I always see these two as these two old men in a coffee shop talking about politics. Have you ever experienced this? You've been sitting near a group of people, a little bit older normally, and they're like, "No, Frank, no, you're wrong. Remember back when Obama was in, oh, you're wrong. What about when Bush was in?" You ever heard nothing like that? No? A little bit? You're all like barely awake, I understand. You should have stopped by a coffee shop this morning. Then you would have heard this shit. So I always see these guys as having opposite views. That's what these are all about. Does this statement have an equal sign in it? No. So it's going to go where? H1. It's going to go on the alternate because it's something I could show evidence for. How can I show evidence that the mean looks to be bigger than 7.25? Find a sample that is way bigger than 7.25. I can show evidence for that. So the claim could be either one of these. Why in this case is it this one? Because it doesn't have an equal sign. So what goes in HO? What's the other dude think? Less than or equal. Now this book is interesting because it bounces between two approaches. Some books have an equal sign here always, and those books are wrong. This book, every now and again it'll say equals goes here, and every now and again it'll say the opposite of this sign goes here. So I love this book, just hedges its bets. It just goes, yeah, both ways. Okay. This next, so that first part is new. Definitely. All right, that's a new thing. But it's just capturing the two standpoints. There's always two standpoints. This second part's old news. Can we use Z-scores, T-scores, or nothing? What do you look for? There's two things you have to find to determine what to use. What's the first thing that tells me I can do anything? What do I look for? What needs to be true for me to do something in Stats 1? No. I mean, I need to know the number so I can do shit with it. But what's got to be true about the distribution? Normal. Is this normal? Yes. N is 41 greater than 30. Check. Now, how do I tell to use Z or T? Why were T-scores invented? Just so we can have another chart to abuse our students with. No. No. Sorry, no. Not when there's no standard deviation, but when we only know the sample standard deviation, right? If I find a sample standard deviation, will that be the same as the population standard deviation? No. I can almost put money on it. I would put money on that. But is that my best guess? Of course it is. It's my only freaking guess. So it's my best guess. So T-scores were invented to cover my ass when I only know S. But which standard deviation do we know in this problem? I know the population. So sigma is known. I know sigma. So then what does that mean? I can use Z-scores. 11. Yeah, I like it. Now, real quick, coming back to this picture since it's still up here. Look, I always get a mixture of people who are bored because they kind of get the idea, and people who are like, what the shit is going on right now? So it averages out to good. What we're about to use on the next step, the next two steps are the most important two steps. Yes?
I have a question.
Yes.
So for n, so for it to be greater than 30, is that just because of the variability, so it's more normal?
Yes, because we have that central limit theorem. This is no matter what it starts off as, if a sample size is bigger than 30, then the sample means will look normal. Yeah, no, they will be normal enough. If this is a percentage problem, I'd have to check NP and NQ. With the results being that if it comes out right, then it's normal. Here, though, if it's not normal, I can still, I'm sorry, if it's not normal, I can't do anything, but if it is normal and I only know S, I can still use T-scores. Okay, yeah. So on this next step, the next two steps, the next step is going to be what's far enough away. And the step after that is going to be how far away did we make it. So if I say I have to be this far away to show evidence that you're full of shit, and you get there, that's evidence that you're full of shit. Now, did you have maybe a bad day? Maybe. But that's evidence that you're not right, that you don't know what you're talking about. So what's going to set up what far enough away is going to be the area in this tail. All right. So let's say, in this case, this guy's claim is true, but he had a bad day. So if he gets way out here, we're going to say he's full of shit. But we want there to be a small % chance that we're wrong. So let me do two things. Let me turn this guy around. Come here. Unzoom a bit. There we go, buddy. Okay, this is huge. Please stand up. There you go, buddy. Well, the real slim key. Okay. Let me redraw another picture. So on this problem, let's talk about this problem specifically. He's fighting against the idea that it's 7.25. He thinks it's longer than that. So, first question I want to ask you right now is something I skipped in the first part. Do you think this is a one-tail or a two-tail test? If he thinks they live longer, where's the only place you can find evidence for that? That the sample is bigger than 7.25. It's a one-tail test. What would make something a two-tail test is if I want to show evidence that it's different from something. What's it mean to be different? Greater or less? That would be two tails. And like I said last time, that really explains why the T-score chart has those two rows at the top. Because they are really set up for hypothesis tests. You're going to have one-tail tests, two-tail tests. And you can look at the right row for that. I like it. So what I need to do is I need to say, this is how far you've got to make it to show me evidence. But what am I going to base that on? I'm going to base that on an area in the tail. So let's say, is it possible? No, stay with me. This is beautiful. I know I say that a lot, but I'll bring you back up in a second. You just lay down for a second. There, I can see Nate. Hey, Nate. Here, I'll just do that so nobody gets freaked out. Okay. What we do in a hypothesis test is we say, okay, let's assume you're right. Let's assume that is mu. So in Phil's case, he's saying, let me assume it's 7.25. I'm going to go do something that's so unlikely, assuming this is true, that this can't be true. We see this in real life all the time. Assuming you're right, look what the hell just happened over there. Right? If somebody's like, well, nuclear plants are 100% safe. No, 3 Mile Island, Japan, you remember all that shit? So it's like, assuming you're right, what the shit was that all about? So if I assume this is right, and I get a sample here, is it impossible to get a sample here if that's right? Is it impossible to get a sample here if that's right? No, it's not impossible, obviously. But I want to control the probability of me being wrong. So if I find, if I want an area here of 1%, can you find the z-score for that? Of course you can. That's an old problem that I was asking you to get you ready for this shit, right? This symbol, I don't know if you guys remember, I think I told you guys this symbol before. Alpha. That's the symbol for the area in the tail or tails. I like it. This is also called the level of significance. So let's really look at this. If I find the z-score that has 1% above it, and I get a sample that's in here, what's the probability that this is still right? 1%. So then it's more likely that this is wrong, that the actual mean is higher. Really, let me say this again. This is huge. And I know I'm boring the shit out of some of you guys. I'm sorry. It's always this is so freaking cool. If I figure out the z-score that has 1% above it in the normal distribution, and I get a sample that shows up there, there's only a 1% chance that that would happen if that was in the right place. So what's more likely? This is in the wrong place. It's probably up a bit. That would be evidence that he's right. Phil didn't claim that the mean was actually 8 point whatever. He just claimed that it was bigger. If I get a sample that's so freaking bigger than this, that's evidence that the whole thing should be moved up. For coyotes in the captivity. You guys kind of with me a little bit. Okay, I like it. Okay, let me see. Let me wake this guy back up. So what we're about to do, oh good, this is exactly, I forgot what the hell my alpha was in this. But that's pretty much exactly. So alpha is 0.01 for this problem. Can somebody please find the z-score that relates to that? Don't say anything out loud yet. Maybe use your t-score chart. It'll get you there so much faster. 1%, one tail. T-score chart. It's just begging to be used for that shit. If I only had one. Maybe I do. No, I don't. Shoot. There we go. Got one. Yay. Oh, what else do you need to know, of course? To use the t-score chart, what do you have to know? But, so I'm trying to trick you a little bit. Is it a t-score I want or a z-score I want? Z-score. Z-score. Where are z-scores always on this chart? At the bottom. So you only look at the degrees of freedom if you stop, t-score. All the way to the bottom, z-score. So for a one-tail test, I don't know why I'm doing that. One-tail test, 0.01. What's the z-score? 2.326. That's where evidence starts. Show me evidence. Okay, where do I have to be? You have to be at least 2.326 standard deviations above the accepted average. Does that make sense? Yes? Maybe? Okay. So let me turn this dude around. Focus. There you go, buddy. I love that you're here, but I can't. So alpha's 0.01. So one-tail test. Let me go back up here, right here. Will it be a one or a two-tail test? I know it's a one-tail test because this guy greater than. That's a beautiful picture of it all. Greater than. If there's a directional word in there. We think it's increased, we think it's decreased, we think it's gone up, we think it's gone down, all that kind of crap. That's one tail. So he thinks it's greater. So it's one tail up here, 2.326. So again, every math class you take, there is what you do and there's why you do it. And the more you understand why you're doing something, the easier it is to remember when to do the right thing. So what the shit is that number all about? It is the z-score that has 1% above it. So if I get a sample in there, there was only a 1% chance to get a sample in there. If that is the real middle. That's why I keep saying this is how far away our sample has to be to show evidence. Blah, 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 blah. Now to put it into words, just to go forward a little bit, on the next step is going to be, all right, we know what far enough away is. How far away did my sample get? That's going to be the next step. That makes sense. What I call that, I'm going to calculate a z-score for my sample. I call it z-star because I'm weird and because we have a stupid z-score up here. I want to differentiate it. So z-star is my z-score. And when I put it in, I'm going to put a little star on it. That's why I call it frickin' z-star. You're not going to see any other teacher do that. Maybe not. I just made that shit up myself. Yeah, I know. So in words, what's got to happen with z-star if z-star is greater than 2.326? Okay. What can we do? Here's what we can do. What does that show evidence for? What does that support in terms of the two old guys in the coffee shop? Which one? The ho or the high? What does that show evidence? If I do get in here, what does it show evidence for? Which one? The alternate, the high. I like it. If you don't like saying the ho and the high, you can call it the null and the alternate. So that shows evidence for this guy, which means it shows evidence against this one. I like it. You can never say this guy looks right because you can never show evidence of equal to with a sample. So here's what it is. If we do get in there, we can reject, you're going to love this shit. Let me just say it technically. You can reject the null hypothesis. You can reject the ho. Which also means you can support the alternate hypothesis. You can support the high. It sounds funny. It sounds like propositions in a California ballot, but all right. You guys kind of yes.
Can you repeat that?
Yes. So, if my sample is more than this far away from what the mean is supposed to be, then I can reject the one that thinks the mean is that. That's the ho. Always going to be this guy. I can reject this one, and I can support this one. That's what this shows evidence for. Does that make sense? I mean, there's two levels to these problems. This is what really trips students up. You feel like if you spend all this time trying to understand the concept, you're not going to know what to do nuts and bolts wise, and that's completely false. You want to really understand the concept, because the nuts and bolts is really nothing new. We're just repackaging this shit. So this kind of makes sense. I've set up, I keep saying that, I set up what far enough away is. So the next thing I'm going to do is, how far did my sample make it? Did it make it far enough away? So this is like my standard of evidence for this situation. Okay. So summarize, so the next part says, summarize the sample information. What do I know from the sample in this problem? Somebody help me out. What's X bar? Do we know anything? What's X bar?
8.65.
8.65. Everybody see that? Back up in the paragraph at the beginning. What's sigma? 3.27. Anybody know what I should I do something with that? Should I do something with that? Yes, because what? I took a sample, and now I'm talking about sample means. So what's got to happen? I got to calculate the new standard deviation, the one for groups of size 41. Somebody help me out. What is 3.27? Somebody with me? Of course we got to do that stuff. Took a sample. I'm talking about the averages. I've got to change the spread number. What do you guys get? 511?
Yep.
So then I can calculate my z-star. The z-score formula, my claim about the z-score formula is that it never changes. It's always my data. What's my data? Freaking sample mean. Minus the middle. In a hypothesis test, we always assume this guy is the middle. Because we're assuming it's right. Look what I just did. That's basically what I want to have happen. Minus the supposed middle divided by the new spread. That's going to tell me how far away my sample got. I know how far away I had to get to show evidence. How far away did we actually get? It's about 2.8 something. I could be completely wrong. Sounds about right. 2.74. I went the wrong. 2.7. I always do that. It's bad job. Divided by a half just doubles the difference. I should have divided by a little more, should have made a little less over. So, just looking at 2.74 standard deviations right now, independent of all this shit, 2.74 steps away, is that very far away? You should be able to say right now, yes, it is. That's pretty damn far away. Because where did unusual start? Way back at the beginning of the course. Unusual started at 2. I'm glad I said that, because I always forget to make this point. In a hypothesis test, we are setting up unusual to be different than 2. In this case, what is unusual? 2.326. Anything past 2.326 is unusual. Assuming 7.25 is the mean, it is unusual to get a sample way out here. And we got a sample way out there. So, HO is the dude, HO is the guy in the coffee shop that thinks it should be in here. We just got something out here. All right, there's my 2.74. So it looks like that guy's wrong. Do you see that? No, yes? Okay. All right, we almost got some of you to sleep. But just keep going a little bit. You guys can get some more sleep. So, I really want you to understand this. The whole step right here, where you got alpha, that's the step that does not happen in real life. In real life, what you see are these things called Pvalues. And then you can make your own conclusion. Stay with me. The p-value is the area and the tail that your z-score makes. What's alpha? Alpha is the area and the tail that this z-score makes. So the p-value is the area and the tail that my z-score makes. Can somebody figure out what that is? I want the area above 2.74. Can anybody look that up? My shortcut lovers, you can do it real quick. My shortcut haters, you can still do it pretty damn quick. 2.74, 2.74. I get this, but why is that not the answer? Because that's the area below, and my tail is above it, so it would actually be 0.0031. So the p-value, 0.0031. What that is, that p-value is the probability that you would get a sample at least this far away. So, would you say that's a really small chance? So, that's the probability. That is 7.25 really is here. The probability that we did what we just did is 0.3%. So what's more likely then is the mean is in the wrong place. Like anything, there's always a chance I'm wrong. Too bad for you, that's how life is. That's why I love statistics. It's the most honest. In algebra, you always get an answer, that's good. And statistics is like, give or take, I don't know. So there is a 0.3% chance that we rejected the null dude when he was actually right. But I can live with that shit. 0.3% chance I'm wrong? I like that. I wish that was always the case. So we can control when I reject or fail to reject. So like if alpha would have been 0.003. I really want this to make sense. If alpha would have been 0.003, we would have failed. What was alpha? Alpha was 0.01. So the area in this whole tail is 0.01. So of course this area tells me we succeeded. It must be out further because it's less. If I made alpha 0.003, this would not have succeeded. We would have failed to reject the null dude. Right? The old guy in the coffee shop with the paper going, yeah, just do it. I think I notice them more because I'm getting closer to being one of them. Right? Sometimes I feel like I am one of them, but oh well. Okay. I know this is a lot to throw at you, but I see more usefulness doing entire problems than what the book does, where they kind of piecemeal it out. When you do your homework, if I were you, I would start with section 9.5, which is complete problems. And then I would go do the other ones because they focus on each piece of the problem. It's a little bit frustrating. As far as I'm concerned, it's like, set this up, but don't go anywhere. Oh, okay. All right. Yes, I am denigrating my book. It's too bad. I didn't write it. So right here, what I can say is we reject the null. This is obviously evidence that he's wrong. Can I state unequivocally that he's wrong? No. There's a 0.0031 chance that he's right. If I reject this guy, that means that I support this guy. So we can always either reject the null, which means support the high. That's one situation. If I say it looks like you're wrong, it means that it looks like you're right. Or I can fail to reject the null, fail to support the high, if I didn't make it far enough away. Yeah, I love it. Now, if you didn't love this stuff already enough, the last step is to write your conclusion. In English, a little paragraph. You don't have to have a thesis statement and supporting arguments and all that kind of shit, but you do have to say something along the lines of this. We have found sufficient evidence. All right, right there. Why can I say that? Because we made it in here. We made it in what I call, now you see why I call it the rejection region. Because what do you do if you get in there? You reject the null. It's a beautiful name for that region. We have found sufficient evidence because we made it into that region. We have found sufficient evidence. Now here's where people now. All right. That first part makes sense, hopefully. This is where people make way too much out of this. And you're like, dude, it's already a lot. I don't have to make too much out of this. By itself, it's too much. What was my claim? Which statement, which coffee dude was our claim, was Phil's claim? Which one? The high. So my conclusion should be about that. What did we do with the high? Support. I got to use this language then. If my claim would have been the hoe, I would have used this language. We have found sufficient evidence to support the claim. Don't put support high. That's crap. Your conclusion has to be all English. We have found sufficient evidence to support the claim that what? And now you can just kind of plagiarize. I allow you to for this specific problem in this specific class. Don't go to English use then, right? We have found sufficient evidence to support the claim that northern Minnesota coyotes live longer in captivity than in the wild. Bam! Do you have to plagiarize? No. You can summarize it some other way, but it has to capture the physical idea. We have found sufficient evidence to support the claim that northern Minnesota... Oh, anybody from Minnesota? Don't really capitalize that. Just kidding. Northern Minnesota coyotes live longer in captivity. Longer? I like it. Live longer in captivity than in the wild. Blah, blah, blah. When you hear something has been clinically proven, this is what they mean. Doesn't mean that they've proven it works all the time. So some drug, does every drug work for everybody? No. My little brother, no pain medication works on him basically. He feels it no matter what. I'm sorry for him, but I won't. Right? He's got to take like a massive amount just to get anything. So, what am I trying to say? So when you hear something's been clinically proven, that means it has met a certain threshold. And as a consumer, I should probably know what that threshold is. I'm not saying you should look that up every time there's a commercial, but I'm like, let me see, what the hell was their threshold? Was it 2.36? Was it 1.03? That's not very good evidence. That's not very far away. So you don't know until you look to see how they set it up. I'm not saying anybody does that, but people have done that. All right. Let's do another one, and then I want you guys to do a couple on your own. I know. Just suffer for a while for me talking some more. Let me give you this sheet here. We're going to do the one on the front together. The one on the back. We'll do understand. Now, I will start this off by saying, I can't remember exactly what year it was that I created this. I know it's within the last 4 years, I believe. But I haven't double-checked these numbers. But you can go to this website, see if there's been any update. CDC. The average age for women in 1990, for when they had their first child, was 24.81 years. We believe the average has not changed. It's just somebody's claim. Right? We just don't think it's changed. It doesn't matter that it's stratified. I just threw that in there so to remind you guys of the word stratified. So we take and plus I think that's how they did it. Take a stratified sample of 264 women who have given birth for the first time and find their average age was 25.27 when they did that. Now again, I shouldn't have to say this, but obviously we can't stop this. It's a sample. It's not good enough evidence. It still could be a mean of 24/81. We've got to see if that is far enough away. Population standard deviation is known to be 5.15 years. The only difference if I just said that the standard deviation from the sample was this, if I said the standard deviation that we find from the sample, that's the only one I give you, what's the only change going to be? I'm going to use T-scores instead of Z-scores. Everything else just stays exactly the damn same, which is awesome. So, help me out here. What is the claim being made? This is where people get freaked out a bit. I was really nice at this problem. Obviously, I'm not going to bold important things in general, but we believe the average has not changed, which means we think the average is equal to what? What number will not show up here? The sample. You're going to state your claim before you even take a sample. So how the hell could it show up in your claim? There's no way. So we think the mean is still 24.81. So which one is that going to be? Is that going to be the low or the high? Yeah, why is it going to be the whole? Has an equal sign. I can't show evidence for it then with a sample. The sample can't show that it's equal to something. The sample can show that it's different. So the ho is going to be, mu is 224.81. What's the high? Is it? I like it. But that's not what we write. We used to write mu less than greater than 24.81. Right? But math people, we don't like multiple symbols in a row. We just don't. We're tricky like that. So instead we just say, what's the opposite of equal to? Freaking not equal to. Yeah. Remember, these two coffee dudes, whatever one says, the other one automatically thinks opposite. You like it? I like this one. I like this one. Very good. Is this going to be a one-tail or a two-tailed test? Why two? Not equal to. What's it mean to be not equal to? You can either be bigger or less. So it's a two-tail test. Why is that important? Because when I go to the T-score chart, I want to know which row to look at. And also how to draw the